Denver International Airport did not just have a baggage problem, it had a machine that became powerful enough to delay the airport around it. The promise was simple: automate baggage at enormous scale, move luggage faster, and make a new airport feel smarter than the old way of belts and manual handling. But the machine did the opposite. Bags jammed, bags went the wrong way, bags got damaged. Timing problems spread through a system that had to act like one perfectly synchronized body. A tool built to speed up the opening became a risk to the opening itself. That is why this story is bigger than one conveyor belt. The failure ate luggage, then time, then money, then confidence in the design. If one conveyor breaks, you fix one conveyor. But what happens when the conveyor is effectively the airport? By the end, the lesson is not that automation is bad. It is that an airport-wide automation system with no room for graceful failure can turn into the bottleneck it was supposed to remove. Denver was building for scale. A major airport is not just terminals, gates, and runways. It is a timed machine for people, aircraft, bags, crews, and expectations. Baggage is one of the least glamorous parts of that machine, but it can ruin everything. If a passenger arrives but the bag does not, the airport has failed in a way everyone can feel. If a bag misses a connection, a flight turn becomes messier. If sorting slows down, workers have to fight the system one cart at a time. So the idea behind automation was attractive. Instead of treating baggage as a slow, labor-heavy chain, Denver could build an airport where bags move through an integrated automated route. That sounded rational, not foolish. The source materials framed the project as a huge attempt to automate airport baggage, and the ambition matched the scale of the airport. The warning sign was hidden inside the promise. The bigger the automated layer became, the more the whole airport depended on that layer behaving correctly. The important point is that this was not automation placed next to the airport as a nice extra. It was automation placed inside the airport's critical path. That changed the risk profile. A late feature can be cut, a decorative subsystem can be ignored, but a baggage layer that the operating plan expects is different. Once airlines, workers, gates, and passenger flow assume the machine will absorb the work, failure becomes organizational instead of purely mechanical. The dream was to make bags move almost like data. A bag would enter the system, be identified, sent toward the right destination, and keep moving without every handoff depending on a person pushing it along. On paper, that is the kind of idea managers love because it turns a messy physical process into something that looks clean and controllable. But luggage is not data. It is heavy, soft, uneven, badly shaped, sometimes badly tagged, and always arriving at the wrong moment for somebody. The system's promise was not just faster belts. It was automated routing across a large airport environment. That meant many pieces had to coordinate: carts, belts, merges, reads, decisions, timing, and the people who still had to work around the machine. This is where the story starts to bend. When a process is simple, one fault stays local. When the process is tightly coupled, one fault becomes a question for everything downstream. Denver was trying to simplify baggage by adding a more complex system underneath it. Here is the core mechanism. The baggage system was not one device that could be tuned in isolation. It was an interdependent network. A bag had to arrive at the right place, at the right speed, at the right time, with the right routing decision attached to it. If a cart was late, the next merge could be wrong. If a bag did not read cleanly, it could be sent the wrong way. If one section jammed, bags behind it did not politely pause in some abstract software queue. They physically piled into a real-world problem. The impressive part was not that Denver built a machine. The dangerous part was that the machine had almost no room to be slightly wrong. Airports already run on narrow timing. Add an automated baggage layer that depends on synchronization, and every small delay can become a systems question. That is the pattern behind the source facts. Scope, hardware, software, and operations were coupled so tightly that production speed coordination became the real test. That kind of coupling is why the failure kept escaping simple labels. Calling it a conveyor problem is too small. Calling it a software problem is also too small. The source pattern points to the combination: mechanical movement, automated routing, sensing, timing, and operational handoff. Each layer could be individually understandable and still produce a system that was hard to run reliably as a whole. The first crack was simple. Real bags are messy. A suitcase does not behave like a perfect box on a diagram. It can tip, slide, twist, hang, drag, or hit another bag at the worst possible point. A soft bag can fold into a space a rigid object would never enter. A heavy bag can punish a weak spot. A damaged tag or bad read can turn a routing decision into a guess. The source failure pattern includes jams, misrouting, damaged bags, and synchronization problems, and those are not separate accidents. They are different faces of the same physical truth. The system was asking real luggage to behave in a clean, automated choreography. When a jam happened, it did not only affect that one bag, it blocked the next bag, then the next movement, then the next promise the system had made. A conveyor problem became a timing problem. A timing problem became a routing problem. A routing problem became an operational risk for the airport trying to open. The second crack was scale. Small errors inside a small system are annoying. Small errors inside a major airport launch can become structural. Baggage sits between check-in, sorting, loading, aircraft turns, and passenger trust. If the baggage layer fails, the failure does not stay politely in the basement. It shows up at gates, it shows up in missed expectations, it shows up in the decision about whether the airport is ready. That is why the Denver case is remembered as a complexity failure rather than just a mechanical failure. The more the airport depended on automated routing, the less room it had for ordinary mess. Every interface became another place where a tiny miss could multiply. The system did not only need to work in a demonstration, it needed to work at airport scale, with real bags, real deadlines, and no patience from the outside world. And that is where big systems become dangerous. The part that was supposed to remove friction can become the part that transfers friction everywhere. The turning point came when baggage stopped being a subsystem and became the schedule. That is the moment every mega project fears. A terminal can look ready. The public-facing airport can look like it is almost there. But if the hidden system underneath cannot support operations, the visible project is not truly ready. According to the source facts, the baggage system problems contributed to major airport opening delays, and the failure was expensive enough to be remembered as a 9-figure automation failure. Those two facts changed the meaning of the story. This was not a quirky technical embarrassment. It was a project risk big enough to reshape the opening logic of the airport. The machine became the gatekeeper. You could not simply wish it into reliability because the failure modes were embedded in the relationship between design, hardware, software, and live operations. This is where the story stops being about luggage. It becomes a question every complex project has to answer. What if the clever subsystem holds the whole system hostage? Once that happens, the victory condition changes. The original dream was broad airport-wide automation. The practical outcome was narrower. The usable system had to be redesigned and limited instead of fulfilling the original promise at full scale. Manual and conventional baggage handling remained necessary, which is the quiet admission at the center of the story. The airport still had to operate after the automation dream failed, so the system had to become less perfect and more workable. That may sound like a boring compromise, but it is actually the key lesson. A redesign is not just a fix. It is a public statement that the original architecture did not survive contact with operations. The system could not be allowed to remain the single elegant answer to baggage. Denver needed fallback paths, narrower scope, and ordinary ways to move bags when the high-tech answer could not carry the whole airport. Relief came only after the ambition was cut down to something the airport could live with. That narrowing is the part many automation stories skip. The fallback was not a defeat of engineering, it was engineering becoming more honest about operating conditions. A robust airport needs more than the clever path. It needs the boring path that still works when the clever path is late, jammed, confused, or not ready for peak load. That is why this failure traveled beyond Denver. It compresses several infrastructure warnings into one visible case. First, scope can expand until no one part is simple anymore. Second, interfaces multiply faster than confidence. Third, testing can miss the cruelty of live conditions because real operations contain timing, pressure, and disorder that staged runs cannot fully imitate. Fourth, automation can remove slack. Slack is not waste when it lets a system absorb mistakes. Slack is what keeps one jam from becoming a whole airport problem. Denver's baggage system is famous because it shows how a tool meant to make a system smarter can make the system more fragile when every dependency is tied too tightly to every other dependency. That is the big systems fail pattern. The failure is not always a dramatic explosion. Sometimes it is a beautiful plan that leaves no graceful way to be half wrong, and then discovers that half wrong is how reality usually arrives. So the lesson is not never automate. That would be too easy, and it would be wrong. Automation can be useful. Automated routing can solve real problems. But automation needs honest boundaries. It needs physical edge cases to be treated as normal, not exceptional. It needs fallback paths that are ready before the launch depends on them. It needs people to ask what happens when a bag jams, when a read fails, when a merge goes out of rhythm, and when the whole system is running under pressure. The Denver story matters because the airport still had to operate after the original automation dream failed. That afterlife is the practical warning. A system can be impressive and still be too brittle. It can be advanced and still need manual backup. It can promise speed and still become the slowest part of the whole machine. The real warning is sharper than anti-technology. Never let a system you cannot gracefully bypass become the gate to opening day. A real fallback is not a press release backup. It must have people, space, procedures, and enough capacity to matter when the automated path is unavailable. Otherwise, the backup is only symbolic, and the project is still betting the opening on one brittle machine. Denver's warning is that resilience has to be designed before the launch crisis, not improvised after the system has already become the schedule. In the end, the baggage system did not only eat bags. It ate the airport's schedule, its budget confidence, and its original operating model. Denver tried to build a smarter baggage future, but the future had to be narrowed, redesigned, and supported by conventional handling because the broad version could not launch cleanly. That is why the case still matters. Big systems fail when the most clever piece becomes the least forgiving piece. They fail when complexity is mistaken for control. And they fail when a project assumes the hidden machinery will simply work because the visible building is almost done. The next time a giant system promises to automate away the messy part, the first question should be simple. If this machine fails, can the system still open, operate, and recover? In Denver, the answer was not clean enough, and the baggage machine became the story of the airport itself.